Okay, the first part of chapter 7 is all talking about the law of sines. So as you look in this blue box here, that's the law of sines. Basically you get the sine of alpha over the side that is opposite of that. So if you notice over here you got angle alpha and the side opposite is A, equals the sine of beta over the side B opposite that, sine of gamma over the side C. Here there's a quick little video there if you want to watch and kind of understand some of the rationale behind it, but in general you have to know the rule and be able to use it. So there's a few different cases, and it kind of goes back to triangle congruence. When we have angle, angle, side, we know the triangles have to be exactly the same, so we can just go ahead and apply the rule as we know. So here we're trying to solve for x. We're going to do the angle that's off that is 70. So we're going to do sine of 70 over x equals, in this case we've got the 50 that corresponds with side 10. So sine of 50 over 10. At this stage, I think the easiest thing to do to solve this is to cross multiply. So you get 10 times sine of 70 equals x times sine of 50. Divide both sides by sine of 50. And you get x equals that 10 sine of 70 all divided by sine of 50. At that stage, I would just type that in your calculator and you get approximately 2.267. Okay, let's look at the next one. If it doesn't give you a triangle, I would always just draw one. It doesn't really matter super what it looks like, just to help you keep things organized. So if this is 95, this is our alpha, the side opposite of that is A, right? Okay, they also gave us a beta, which is 85. So the side opposite of beta is going to be B. And then we don't know this angle at the top, but we do know the last side is 33.3. So if you wanted to find that last side, think about doing 180 minus 95 minus 85. And notice just right then when you do that, you end up with 0. So is it possible to have the last degree to be 0, or even for that fact negative? And the answer there is no, it's not a triangle then. So this does not create a triangle. Or in the homework, they'll often have you write like DNE for does not exist. Okay, the next case is angle side angle. So that means you have the side that's wedged between the two angles we know. So if we draw this picture, we've got 85 degrees, and we've got the side A that's opposite that. We got 30 degrees, and we got the side B that's opposite that. And then our last side here is 5.25. When it says solve the triangle, in general, they want to know all the sides and all the angles. So let's start with the angle on the top. So to find that, we're going to do 180 minus 85 minus 30. And that's because, remember, all the angles in a triangle add up to 180. So this is 65 degrees. Once you've got that, I can talk about the sine of 65 over 5.25 equals, and now choose either A or B to solve for to begin with. So if I did like sine of 85, I'm going to put that over the side A. Do your cross multiplying, we get 5.25 sine of 85 equals A times sine of 65. So divide both sides by sine of 65. And then type in your calculator, 5.25 sine of 85 divided by sine of 65. And we end up that A is 5.771. We can do the same thing, and I usually take what I already knew, so like sine 65 over 5.25. But then this time, I'm going to use my sine of 30 all over the B. So think once again about cross multiplying. So we get 5.25 sine of 30 equals B times sine of 65. Divide both sides of the sine of 65. So now B equals 5.25 sine of 30, all divided by sine of 65, so it equals 2.896. And now we've solved for the triangle. We have all the kind of missing sides and angles. Something like to kind of self-check your work, whatever the largest angle, so in this case 85, should be across from the largest side, which is 5.7. Or like the smallest angle, which is 30, should be across from the smallest side, which is 2.896. So that does match up. Okay, so now let's look at angle side. The problem with this one is, if you think about having an angle and then two sides, you could produce two different triangles. So if you look over here on the right, we have a congruent angle A, but then we have the two sides that are equal, and we could get an acute triangle like the one on the left, or we can get an obtuse. So we're going to have to remember that as we go through these examples. There may be two different answers. Okay, so let's look at our triangle here. We've got alpha equals 86.7. I'm going to put that across from A, which they actually tell us is 88. If I say this is beta, I'm going to label this side as 92. So then we've got gamma up here at the top. And then we got side C. So now if we think about solving for these, we would do the same thing that we've done before. So like sine of 68.7, all divided by 88, equals sine, let's say I probably would start with beta because we have the side across from that. So beta all over 92. Think about cross multiplying. So 92 times sine of 68.7 equals 88 times sine of beta. Let's divide both sides by 88. Now this time I probably would evaluate the left side, so 92 times sine of 68.7 divided by 88 equals 0.974 sine of beta. So to get beta, we're going to do the inverse sine of 0.974. So inverse sine of 0.974 is equal to 76.9 degrees. Okay, so you think about this as being 76.9 degrees. And if that's true, then we can solve for the other side. So if I look at the top angle, I'm going to do 180 minus 68.7 minus 76.9, and we get this top is 34.4. So then the last thing to solve for here is this C. So we would do sine of 68.7 all over 88 equals sine of 34.4 all over C. Do your cross multiplying, and you may start to recognize that C will equal 88 times sine of 34.4 all divided by sine of 68.7. Type that into your calculator again, and you will end up with 53.36, so we'll just call that 53.4. Okay, so that's great, and that's when we have a acute triangle. I'm going to go over here on the right side just because I kind of ran out of room. So the triangle will now look obtuse, so something like this. Maybe I should draw it a little bigger. Let's see if I can do it a little bigger. So this is still 68.7, but this time your beta, if we got originally that it was 76.9 degrees, think about all students take calculus, and the second quadrant will also be positive. So if I take 180 minus that 76.9, I will end up with 103.1. So therefore, if I do 180 minus the 103.1 minus the 68.7, my last angle up here is 8.2 degrees. Okay, so A is still 88, which will still be across from that 68.7. B is still 92 over here. And the last side we have to solve for here is C. So I'm going to do sine of 68.7 divided by 88 equals sine of 8.2 divided by c. Similarly, I could have done sine of 103.1 divided by 92, and I would have gotten the same result. So cross multiply, and we get that c equals 88 sine of 8.2 divided by sine of 68.7. So type that in your calculator, and we end up with 13.47. So I'm going to call it 13.5. And notice how we started the same problem, but we ended up with two different results. Okay, let's look at one last one then. So once again, I'm going to draw the triangle. I've got 42 degrees. And then the side opposite that is A, which is 39. I've got beta that I don't know, but I know the side opposite that is 23.5. I've got gamma, which I don't know, and the side opposite of that is C. So I would start in the same way that we did the last one, where you're saying, okay, I've got sine of 42 over side 39 equals sine of beta all over 23.5. So cross multiply, and you'll end up with sine of 42. Actually, I'm going to put the 23.5 up front. So 23.5 times sine of 42, because you're just less likely to make mistakes in your calculator when you have it written that way, equals 39 times sine of beta. So divide both sides by 39, and we get sine of beta. So let's evaluate that on the right. 23.5 sine of 42 divided by 39 gives you sine of beta equals 0.4032. So then inverse sine of 0.4032 equals your beta, which gives you 23.8, we'll round that to degrees. So this is 23.8. So then if I do my 180 minus 23.8 minus 42, this top angle is 114.2 degrees. Okay, to solve for that last side then, I could set it up the same, like sine of 42 over 39 equals sine of 114.2 over c. Do your cross multiplying, and I think you've kind of picked up that it's 39 times sine of 114.2 divided by sine of 42. At which stage you type that in your calculator, and you end up with 53.2. We'll round that to. So 53.2. Okay, do the same thing, but then you're saying, okay, well, what if my triangle had this as the obtuse angle? So this is 42, 23.5, this is still C, so this is gamma. So let's talk about B. So we'd have 180 minus 23.8, which is 156.2. So now if I try to solve for gamma, I would do 180, sorry, I should have written that different spots, minus the 42 minus 156.2. And you'll notice there that that gives you negative 18.2. So the issue is that these two angles are larger than 180. So therefore, this one does not exist. It has to be an acute angle triangle based on the size